Hi everyone, it's Mr. Campagna. So today's lesson has kind of an interesting series of images in it, and I'd like to take a moment just to maybe try to clarify what those images are trying to show. So a couple slides in, they show you an image of North America, and they've taken a path starting off in Kodiak Island, Alaska to the southern tip of Greenland. And you can see how the pathway runs in a straight line, because even if you are on a globe, which most directions, if you travel on the globe, will produce a curve, in this instance, I would assume that they're doing this from a top-down view, so it appears to be a straight line. You can see how the line is very much to the north and it misses Hudson's Bay. Well, on the next slide, they show how on some projections of the globe, because remember, the globe is a round three-dimensional object and a map is a flat two-dimensional thing. If we spread out the map to make it two-dimensional, it actually pulls that line down a bit. Now, I cannot get this exact demonstration to replicate, but I can show you something that is very similar and it still illustrates the same point. So here's an image of the Earth, and if we were to actually cut into it, and here we've got, what, 6 different slices, and you were to open it up like this and then push them flat, maybe peel the crust off the actual Earth, you'll notice that we have to fill in the gaps somewhere. So you're going to be stretching those parts towards the poles out to fill in the blank areas. In fact, on a map like this, the only area that's anywhere near correct would be right on the equator. So if we take a look here, you can see that there is very much quite a bit of the globe missing. And because of that, when we stretch those pieces to fill in the voids, it distorts our view of the Earth. In particular, this completed projection is known as the Mercator projection, and it's one of the least accurate yet most used projections of Earth. It makes Greenland look enormous, when in reality, it's not a giant monster continent. It's actually much, much smaller. So back to our globe, you can see here that Greenland really isn't much larger than, let's say, Saudi Arabia. They're pretty comparable in size. Let's see what happens to this straight line when we take the globe and we open it up and push it flat into a two-dimensional object. So as you can see here with the dashed red line on a two-dimensional surface, that does not match the straight line that we see on a globe. And this is why the flight path of an aircraft looks curved when the plane is actually traveling the shortest distance between 2 points. The Mercator projection is not accurate with the exception of the equator. Why the difference? The actual space occupied by the Earth is three-dimensional and spherical. When that space is altered in order to fit in a two-dimensional sheet of paper, the actual geometry of the surface is altered. A straight line on a curved surface does not mean the same thing as a straight line on a flat surface. When an object travels through curved space, it must follow the curvature of space in order to move in a straight line. When there is no mass in a volume of space, the space is not curved. An object passing through space would follow in a straight line in our normal way of thinking about a straight line. When a large mass is placed in space, however, the space is curved due to the presence of the mass. In this case, an object passing through space must follow the curvature of the space in order to follow a straight line. Thus, the path of the object bends towards the mass. The change in the direction of the object appears to be exactly the same as it would have been following Newton's law of gravity. I'd like you to answer this question. When does Newtonian physics no longer work to explain an object's movement? So all in all, pretty interesting aspect about the universe we live in. So I hope this was helpful. Thanks for watching.